Nitrogen is an important part of life on Earth. One of the four most common elements, nitrogen is essential for the composition of living things, helping build proteins, DNA, and RNA in biological life. However abundant this element is, it is not easily accessible to biological life. Nitrogen must be fixed to the soils in order for it to be accessible to producers, and thus, the availability of nitrogen controls the overall productivity and quality of life within an ecosystem. There are two ways which nitrogen is made available naturally: through fixation by specialized bacteria, which lives in symbiotic relationship to specific plants, and through lightning strikes, which causes atmospheric nitrogen to bond with oxygen to create nitric oxide. This limited availability within ecosystems maintains the delicate equilibrium of nutrient cycling through life in the system. As nitrogen is essential to the composition of living things, it follows that the availability of nitrogen is essential to successful agriculture. This relationship between nitrogen and agriculture was finally understood in the late 1800s and served as the basis for the growth of modern agriculture into the mid-1900s. With the discovery of this relationship, the push began to discover more effective ways of providing nitrogen to agricultural operations. As the Industrial Revolution continued, levels of prosperity soared and population sizes increased. It now became essential to the quality of human life that nitrogen be supplemented into agricultural operations to provide the supply for this new demand for food. In 1909, a scientist named Fritz Haber became the first person to successfully fix nitrogen synthetically. By the 1940s, the true industrialization of agriculture began with the use of Fritz Haber's process to synthesize ammonium nitrate as a vehicle to provide nitrogen fertilizer to agricultural soils. This allowed for the explosive growth of agribusiness and the formation of commercial agriculture as we know it today. It is estimated that 99% of today's inorganic nitrogen fertilizer is provided by the Haber process, and this fertilizer provides essential nitrogen for at least 2/5 of the global population. This number only rises as our population size continues to expand. If we apply our knowledge of the role of nitrogen and the nitrogen cycle, there can be no doubts that our increasing the availability of this element will have strong impacts on ecosystems. Nature has limited the availability of nitrogen within ecosystems with reason. Ecosystems have only a limited capacity to sustain life, and an equilibrium point of productivity must be maintained so that the processes of the ecosystem can continue to run smoothly and efficiently. While the natural limits of nitrogen within an ecosystem create a negative feedback loop, limiting the overall productivity of the ecosystem, human intervention alters this, increasing the burden on the ecosystem and damaging the ability for it to sustain itself into the future. Understandably, there are a large number of ways in which this takes place. I can only cover a few of them, but they do extend outside of these. As we have seen, increases in the nitrogen level in water causes a phenomenon called eutrophication. Mismanagement and improper use of agricultural resources causes nutrients such as nitrogen to leach into soils, groundwaters, and into surface waterways. This sudden abundance of nutrients increases the ability of phytoplankton in the water to photosynthesize, increasing the overall population and raising the overall productivity of the ecosystem. This imbalanced increase of nutrients and the productivity of these ecosystems creates a strain on resources, and the decomposition of these phytoplankton decreases the level of dissolved oxygen in the water. These hypoxic conditions either kill or force out the organisms which normally reside in the habitat. This process greatly reduces the biodiversity of the ecosystem and creates lasting and possibly irreversible effects on the ecosystem's function. As anthropogenic nitrogen fertilizers are less bonded to the agricultural soils, and as the watering practices of large agricultural operations inefficiently flood the surface soils, these sources of nitrogen fertilizers are easily washed away and into the water supply. Compounding this issue is the destruction of natural lakes and wetlands, which in part serve a function of denitrifying surface waters. The loss of these natural sources of water denitrification has decreased the ability for the waterways to handle increased nitrogen inputs and increase the effects felt from our agricultural practices. The use of nitrogen fertilizers also affects atmospheric levels of gases such as nitrous oxide, nitric oxide, methane, and ammonia. Just as the overuse and mismanagement of modern agricultural practices affects nutrient levels in waterways, these same tactics also increase the emission of these gases from soils and water bodies into the atmosphere. One example worth highlighting of the problems this causes is nitrous oxide's role in global climate change. Nitrous oxide is an extremely effective greenhouse gas, contributing more to global warming than carbon dioxide. It is estimated that nitrous oxide is responsible for 5% of the greenhouse effect, while 70% of this gas comes from animal and crop production. These gases are also accountable for the alteration of nitrogen cycles in ecosystems not necessarily connected to ones where anthropogenic nitrogen fertilizers are used. Through atmospheric deposition, closed nitrogen loop ecosystems, such as rainforests, received increased nutrient inputs, which cause alterations to their nutrient cycles. Much like eutrophication of water bodies, the deposition of nitrogen into these closed-looped ecosystems increases the productivity of the ecosystem and overstrains the delicate balance of biological life. The difficulty in prescribing solutions to these problems is that there is no complete one-step solution. While a reduction or complete removal of anthropogenic nitrogen fertilizers from agricultural practices would be a potential remedy to these problems, such high numbers of the world's population subsist off of food produced in this manner that abolishing these fertilizers immediately would cause increases in food prices and decrease the overall food supply. We need to ensure that we are capable of providing adequate nutrition globally before cutting down the global production of food, as it would not be fair to enact policies which disproportionately affect individuals and nations dealing with low economic and agricultural resources. These tactics need the utmost discretion and can likely only be applied in affluent countries capable of providing the resources necessary to take on these changes. Some actions which can be taken involve an increase in the use of organic and traditional farming methods, which do not rely on inorganic fertilizers. While this does cause an increase in the overall cost of food, the benefits to human health and the minimization of environmental effects far outweigh the monetary costs. There are issues with this, of course, but there is no first world country that would not benefit from this change. Those countries whose population growth outpaces their economic growth and political stability will predictably have problems making these sorts of changes, and it is a serious question that this may not provide adequate levels of food production to meet the demand from the population. For this reason, it may not be feasible to implement these changes elsewhere, but the changes in the first world countries could begin to offset the global impacts of agriculture in developing and disadvantaged countries. Education can also be used to reduce our impacts. Providing a better understanding of daily nutritional needs and the ways to satisfy these would help people to consume more responsibly and live healthier lives. This would also hopefully decrease market demand for those foods whose environmental costs outweigh their nutritional benefit. As the consumption of animal products is certainly not necessary to an individual's survival, and considering that the production of animal agriculture increases nitrogen resource inefficiencies, which endangers the well-being of ecosystems and the future of human populations, the imperative of reducing or completely eliminating such diets based in animal products is apparent and correlates with its ease of possibility and the low-level risk of such action. If this action is taken universally, the current population levels could be sustained with at least a reduction in the dependence of anthropogenic nitrogen fertilizers and more evenly distribute the use of nitrogen fertilizers based on practical necessity. This will cause a decrease in the introduction of these fertilizers into the environment, which may buy time to increase the effectiveness of our steps to change such impacts. Additionally, further research and innovation regarding current and future uses of nitrogen fertilizers is necessary, both to understand their proper application methods and the requirements of the products produced for food. As our understanding grows, it is possible to increase the efficiency of our use of these products, which seem harmful to the global and local environments, but essential to the sustaining of current population levels. We must also increase our understanding of the natural denitrification processes and decrease our impact on these, so that nature can at least have a chance in managing our effects. Clearly, a cultural shift must happen in our understanding of the priorities of agriculture and agribusiness. These problems present as evidence to the fact that profits must no longer be the motivating factor in the production of subsistence foods. As profit incentives increase, as we have seen drastically through the last century, and growing still throughout the current one, there is a perversion in the priorities of the business models in these industries. Ecological responsibility is pushed aside to make way for larger production yields with lower capital costs, all the while food prices increase. The benefits of these processes are felt by few, but the effects are felt globally and across all species. Bringing this down to the level of the individual American, responsibility in consumption becomes key. While individuals within the population have an understandably varying capacity to make changes to their levels and means of consumption, it is imperative that individuals begin to factor in the long-term costs of their consumption as they exist in non-monetary terms. As unnecessary overconsumption increases the burden of the individual on the ecosystem, it needs to be understood and considered within the realm of individual consumption that the impact of our choices grows and compounds as we consume outside the realm of necessity, and that these impacts affect not only human life, but also the non-human biological life which also inhabits our ecosystems. If we can adjust the considerations we make to the ways in which we consume, and we attempt to reduce the impact of all human actions, we can make some progress towards fixing the current situation.